John Legend. Okay, last type of approximation is called final method is called the trapezoidal rule. Trapezoid. You have to say trapezoid like that. Trapezoidal rule. Robots say zoid.
Is this only for curves?
It's for anything. It could be straight lines. It'll work for anything.
For a star?
A straight line, but how would you find the area is a straight line?
Well,
As long as, so it has to be like a shape?
any function you can do it for. Right, it could be an ellipse. Because look, if you had a rectangle, let's just say you had a constant function, the area under that would be super easy. You wouldn't have to approximate it. You could find the actual area, the exact area. Okay, so trapezoidal, I'm doing now from where to where?
0 to 8.
0 to 8. And because this picture isn't the best, I'm gonna just draw right here. Because I think that works just as good. So using how many trapezoids? 4 trapezoids. So this is going to be interesting.
We just make the base bigger.
So here's the thing. I'm only going to be in the first quadrant. So I'm going to draw like this. This is 8. This is 0. I need to break it into 4 trapezoids, so it's going to be 1, 2. So it's going to be 2, 4, 6. It's what? Is it? Okay, this isn't working. There we go. You're weird. Whoops.
Where's 4?
Where's 1? Why is there a 1?
No, that's from the 4.
Oh, it's right there. We see the bottom. The 4's in 5.
Oh.
Got cut off.
No, but the 8.
Yay.
It died.
Okay, 2, 4, 6, 8. So let's look at trapezoidal rule. It's gonna look like trapezoidal rule. No.
Is that recording?
I have to break it up. I have to chop it up 15 minutes at a time. Alright, so I'm gonna need 4 full trapezoids. So the first trapezoid is gonna look like this. From here to here. Then I also have a point here and here. And my trapezoid will be, these will be the parallel sides of my trapezoid. And this is usually the angled side of the trapezoid. Okay? Right here it looks a lot like a rectangle because it doesn't curve as much. But let me move further down. The next trapezoid is going to look like, starting up here, it'll go down to 4, like that. Trapezoid is really good. That tends to be the most accurate. So I'll draw the third trapezoid. So the drawing part isn't that bad. It tends to be harder to do the actual the math behind it. Take a look at this last trapezoid. I'll start this one.
Does it really have
Where is the other point to go to?
It's a triangle.
It's at 0. So instead of a trapezoid, you end up having a triangle. Or in our case, looks kind of like a banana. Okay, so let me do the math. I'll color code the math. Make sure you're paying attention to this. What's the area of a trapezoid?
Divided by.
Okay. 1/2 base 1 plus base 2 times the height. Okay, you guys were thinking triangle. You were thinking triangle. A trapezoid is basically a triangle with 2 bases. Look at the area of a triangle. Area of a triangle is 1/2 base times height, whereas a trapezoid just has 2 bases and you add them. So they're very similar shapes. They're like cousins. They're like primos.
Okay, mister?
Hmm.
Primos.
Primos.
I want to hear you say it.
What?
Say trace. Say it. Trace. What were we doing? Oh yeah, calculus. So what will the area be for? No. What will be the area for this guy? For this trapezoid, the red one. This is a tricky part. Okay, so I know I have to have the half. What is the height?
The left side.
No, the height is 8.
It's 8. The radius. The left side. No. It's
The height is 2.
Oh, because we're the
Turn your head. The trapezoid is not standing up. The trapezoid is on its side. See, the bases of a trapezoid are always the sides that are parallel. This side is parallel to this. These are the bases. So base 1 would be this one, and base 2 would be this side. Okay? And then the heights are the bottoms. And they're always the same here. In this case, they're always the same. Sometimes they change. They talk about we'll run into the problems where we don't have
Jesse dropped his calculator. What do you got?
drop the Rubik's Cube. Okay, so what's base 1 gonna be? Not those.
Settle.
8.
Oh.
This is 8. Plus, what's this height gonna be?
8.
No, it's not quite 8. It's
Right.
7.9 or something. You're gonna have to do f of 2, which is what?
7.937.
Use the calculator. It's already in the calculator. 7.937.
Wait, mister, why'd you plug in the 7.7?
I don't know. I just said that number.
Well, here. Oh, you did? You liar. Okay, so trace. I'm gonna hit 2. 74746.
You're way off.
Yeah, you were kind of close.
7.74
6.
or 6.
Okay, so you see how to find that all this work is for one trapezoid, this one.
Oh my god. So you plugged in 2 to find the base on like the B2?
in this case it was this B2. So let's do the math to find this one.
So you'll be using that one for both ones.
So the area for that light blue one is going to be 1/2.
7.7.
And then we know the height is also 2. Because it's down here, the height is 2. But now the two bases, I'm going to be able to recycle one of these numbers. I can recycle 7.746, since that's what this side is. Then the other side is going to be found by evaluating where? F of what?
4.
F of 4, which calculator buddy is going to help me. 6.928. So that gives me the area of light blue trapezoid. Okay, find the other trapezoids on your own. Pi o'clock. Okay, can you guys join the class?
Isn't it second trace?
Yes, it's under second trace. This one. And it would be from 0 to 8. And again, the trapezoidal approximation should be less than 50.265 or 0.266 because it's an underestimate.